Lab 1, Charged Tape by Chandler Pittman. So, a little bit about our table of contents, what we're going to be talking about today. First is the introduction of the experiment. Second is our equations. Third is our experiment. Fourth, we're going to talk about the model. 5, we're going to talk about the results. And then 6, we're going to talk about our analysis and conclusion. So first, our introduction. So what are we trying to figure out and why? So what we're trying to figure out is how tape, when it's charged, acts with other objects, whether that be a charged object or an uncharged object. And next, for the why are we trying to figure this out? We just want to be able to show what happens when you turn an object from uncharged to charged. And we want to show how they interact when both are charged, or when one is charged and one isn't charged. So second, equations. When we're talking about the equations we use 3 main equations. The first is the electric force equation. So the electric force equation is the electric field of a point charge times the charge of another object, which would be Fe equals Qa times Eb. Next, we use the electric field equation, which is used to calculate the electric field. And this is E equals Kq divided by d squared. And finally, we use the gravitational force constant. So the gravitational force constant is Fg equals 9.8 meters per second squared. Third, let's talk about the experiment. So, let's talk a little bit about our experiment. So first, for our single U-tape experiment, we created a U-tape and created a base tape that was then put on the table. We took the U-tape, ripped the U-tape off of the base tape to give it a non-zero charge. After it was given a non-zero charge, we then compared that U-tape to our finger and a pen. So when we were kind of looking, is a U-tape positively or negatively charged and how it was attracted, first, when we compared it to the finger, we looked and realized it was attracted towards the finger when it was non-zero charged. However, when we put it near a pen, it was attracted to a neutral pen or an opposite charged pen. However, when the pen was the same charge, it was repelled. Next, when we kind of looked at the U-tape interactions, we first created a second U-tape to compare to the first U-tape. When the U-tapes were put together near each other, they have the same charge, so they were repelled from each other. However, if either of those tapes had a different charge, then they would have been brought together. Next, let's talk a little bit about the model. So now let's talk a little bit about our model. On the left, you can kind of see all the different equations and functions I used to get this picture on the right, this model on the right that I made. As you can kind of see, each piece of tape is a charged particle, or is modeled as a charged particle with different forces acting on it. If you look at the bottom, it's kind of held at the same place, so there's only that one force acting on it. However, if you look at the top, it has a net zero force. This would be due to the fact that there's an electric force and a gravitational force acting on it, therefore making it a net zero. This model is then confirmed by our results and our calculations. So if you kind of look at the results and the calculations that I did, you can see that it kind of gets to the same result and conclusion that the model does. If you look at the top left, you can see the measurements I made. So first, the distance between the two tapes is 4 centimeters or 0.04 meters. The mass was 2.4 times 10 to the negative 4th kg. The length was 24 centimeters or 0.24 meters. The width was 1.8 centimeters or 0.018 meters. And then if you look at the top right, I calculated the force for each of the tapes, and I ended up getting 6.47 times 10 to the negative 8 coulombs. I also kind of determined with the number of atoms as well as the number of electrons on each piece of tape. That ended up being, for atoms, 1.375 times 10 to the 17th atoms, and electrons, I ended up getting 4.04375 times 10 to the 11th electrons. So finally, let's kind of look at some of the analysis and conclusion that we can gather from this. So let's kind of look at some of the analysis and conclusions that I made. So first, assumptions, meaning kind of the main assumption we made throughout this project was we assumed that each piece of tape had exactly equal charge and that there was an even distribution of electrons and atoms throughout. So it's kind of a big assumption. But when it comes to meeting and why did we do this experiment, throughout the experiment we were able to determine attraction and repulsion interactions between the tape and other objects. And like we said earlier, U-tape was attracted towards the finger when it was non-zero charged and attracted to a neutral pen or opposite charged, but repelled the same charge. And finally, calculated the electric charge, forces between charge, and the electric field. A little bit of sources of error I found were first, human error. So this could have been incorrect observations or touching the tape. We have the induced charge error. So objects near the tape would become polarized, which may have affected the electric field. It may not have, but it could have. There's a changing charges error. So pulling tape of a surface may not transfer uniformly. And finally, the environmental error, which, different surfaces, bad contact, the surface material, and even the stickiness of taste could all have been factors for sources of error. Thank you.